Namaskar. Today we are going to discuss on National Mathematics Day and mathematics as India's intellectual heritage. Mathematics in India is not merely a technical discipline, it is a cultural and civilizational achievement that evolved alongside philosophy, astronomy, architecture, music, and trade. Long before mathematics became formalized in the modern Western sense, Indian scholars were using numbers, patterns, and logical reasoning to understand the universe and solve practical problems. National Mathematics Day, yes, celebrated every year on 22nd of December, commemorates this legacy through the life and work of Srinivas Ramanujan, the self-taught mathematical genius born on that date in 1887, one of the greatest mathematical minds in history. The day reminds us the mathematics is both creative and transformative, shaping science, technology, and everyday life. This day promotes appreciation for mathematics' role in science, technology, and daily life. It began in 2012, declared by the Government of India during Ramanujan's 125th birth anniversary celebrations at Madras University. Government of India established National Mathematics Day on December 26, 2011, with the first observance on December 22nd, 2012 to commemorate Ramanujan's legacy in number theory, infinite series, and partitions. The initiative aimed to inspire students amid India's rich mathematical heritage, from ancient scholars like Aryabhatta to modern innovators. Events often include competitions on the theme like Indian mathematics and its appreciation. Srinivas Ramanujan, born on December 22, 1887, stands as the central figure of National Mathematics Day, with his self-taught genius yielding nearly 3,900 results that revolutionized number theory and analysis despite minimal formal training. Srinivas Ramanujan grew up in modest circumstances with little formal education. He relied on intuition, self study, and extraordinary pattern recognition. By his teenage years, he had independently rediscovered and extended advanced mathematical ideas, recording thousands of results in notebooks filled with insight but few proofs. When Srinivas Ramanujan sent his handwritten formulas from India to Cambridge University, many mathematicians were puzzled. But one mathematician, G. H. Hardy, a leading British mathematician, immediately sensed that these ideas were extraordinary and could only come from a rare genius. Hardy invited Ramanujan to England, where the two began working together. Hardy helped give formula proofs and structure to Ramanujan's intuitive discoveries, while Ramanujan's intuitive discoveries amazed Hardy with his natural ability to see deep patterns in numbers without long calculations. This partnership combined intuition and logic, producing groundbreaking results in number theory and mathematical analysis. Hardy later said that Ramanujan was among the greatest mathematicians of all time, placing him alongside legends like Euler. Their collaboration transformed Ramanujan from an unknown clerk in India into a global symbol of mathematical brilliance. Ramanujan discovered hidden patterns in numbers that no one had seen before. He explored how numbers behave, how endless calculations in finite processes work, and how mathematics reflects patterns found in nature itself. Today's Ramanujan's ideas are everywhere, often without us realizing it. Cryptography, keeping online messages and payments secure. Physics, understanding the universe from tiny particles to cosmic mysteries. In computer algorithms, making software faster and smarter. And in data science, finding patterns in large amounts of data. In simple words, Ramanujan's mathematics is like a secret code of numbers that helps modern science and technology work smoothly, even in apps and devices students use every day. Ramanujan believed that mathematics was not just a human invention but a divine gift. He often said that his ideas came to him through intuition and prayer, and he credited the goddess Namagiri for inspiring his discoveries. For him, numbers were alive with meaning, not just symbols on paper. Ramanujan's famous belief that an equation has value only if it reveals a deeper truth shows how he connected science with spirituality. This unique blend of intellect, humility, and faith makes Ramanujan not only a mathematical genius but also a source of deep national pride for India. His life reminds us that great knowledge can grow from simplicity, devotion, and inner strength. Now we are going to discuss about the human side of a genius. Despite being recognized as one of the greatest mathematicians in the world, Srinivas Ramanujan remained a simple, humble, and deeply spiritual person throughout his life. Born in modest family in Tamil Nadu, he never forgot his roots, his culture, or his faith. Even when he worked at Cambridge, alongside famous scholars, he lived a disciplined and austere life, focused more on ideas than on fame. Ramanujan independently derived formula for infinite series, continued fraction and partitions by age 16, inspired by a borrowed book like Carr's Synopsis. Ramanujan recorded many mathematical results in his notebook without formal proofs, relying on deep intuitive insight that he believed had a divine source. British mathematician G. H. Hardy rigorously examined and validated many of these results and judged Ramanujan's mathematical depth to be on par with legendary mathematicians like Euler and Jacobi. Ramanujan made path breaking contributions to number theory by uncovering deep patterns in number that mathematicians had never noticed before. One of his most famous achievements was in understanding partition numbers, that is, how many different ways a number can be written as a sum of smaller whole numbers. He discovered a powerful method to estimate these numbers even when they become extremely large, a breakthrough that later became fundamental to combinatorics and mathematics as a whole. Ramanujan also worked on highly composite numbers, which are numbers that have more divisors than any smaller number. His ideas help mathematicians better understand why certain numbers appear more frequently in nature and calculations. Ramanujan identified special types of prime numbers, now called Ramanujan primes, which deepened our understanding of how prime numbers are distributed. Perhaps most remarkably, he introduced mysterious mathematical objects called mock theta functions. These ideas were far ahead of their time and were only fully understood decades later. Today, they play an important role not only in pure mathematics but also in modern physics, including research on quantum theory and even the study of black holes. In simple terms, Ramanujan's work revealed hidden structures in numbers and opened entirely new directions of research that continue to influence science today. In finite series of pi, Ramanujan found special mathematical series that reach extremely accurate values of pi were quickly allowing many digits of pi to be calculated with far fewer steps than earlier methods. It means faster way to calculate pi. Listing impact on modern computing, these ideas later became the foundation for today's high-speed computer algorithms used to calculate pi and influenced advanced areas of mathematics and physics. And yes, if we talk about modern legacy, and it is relevant today. Ramanujan's ideas are still used in modern fields like computers, artificial intelligence, and advanced physics. His work helps in solving complex problems faster, improving calculations, and checking the accuracy of large amount of data. Beyond numbers, Ramanujan believed mathematics was not just calculation but way to understand deeper truth of the universe. As Ramanujan himself said, an equation for me has no meaning unless it expresses a thought of God. This thought continues to inspire discussions on whether mathematics is invented by humans or discovered as a universal truth. Why Ramanujan matters today? Ramanujan's work affects us more than we think. In black holes, his mock theta functions written on his deathbed are being used by physicists today to calculate the entropy of black holes. Internet security. His work in number theory helps create the locks that protect global digital communication. And in artificial intelligence, the algorithms used to process massive amount of data often used series and partitions influenced by his formulas. Now we are going to discuss about the Indian legacy, intellectual legacy of mathematics in India, and ancient mathematics history we are discussing now. Indian mathematics date to Vedic times, 1500 before Christ, evolving through texts like Sulba Sutras for geometry in altar construction, emphasizing precise ratios. Key figures including Pingla, 300 BCE, who developed binary sequences, and Pascal's triangle precursor, Meru Prasthara, for prosody foundational to algorithms and computing. The decimal place value system emerged by 500 CE, enabling complex calculations. And what are the key discoveries? Aryabhatta, 476 to 550 CE, approximated pi as 3.1416. In Aryabhatiya, recognizing its irrationality and used algebraic methods for astronomy like eclipse predictions. Brahmagupta, 628 CE, formalized 0 as a number in Brahma Sfuta Siddhanta, defining operations like any number times 0 equals 0, revolutionizing arithmetic alongside the decimal systems. Bhaskara II, 12th century, advanced algebra, trigonometry, sine tables, and calculus, precursors like Rolle's theorem. Zero and decimal notation underpin positional arithmetic, essential for computers and spreadsheets. Yes, we are talking about digital technology links with our ancient mathematics discoveries or achievements. Pingla's binary system and radix convergence prefigure digital logic, gates, and data encoding in AI. Indian concept like infinite series, like Ramanujan's contribution and algorithms influence modern cryptography, uh, machine learning, optimization, and compression core of smartphones, blockchain, and simulations. Pre-zero foundations around 2700 to 1900 BCE, Indus Valley artifacts show early decimal like weights, 1, 10, 100 ratios for trade, hinting at positional concept without zero. Vedic Sulba Sutras 800 to 500 BCE used geometric ratios for ultras, employing power of 10 implicity but treating voids verbally as sunya, empty. Ancient roots mathematics in early Indian civilization. When we talk about Indian Valley foundations, archaeological evidence from the Indus Valley civilization shows standardized weights and measures based on decimal like ratios. This indicates an early understanding of number scaling, precisions, and proportionately essential for trade, construction, and governance. The practice era, the Indus Valley, 3000 to 1500 BCE, before the wheel was used for chariots. It was used for precisions. The Harappan civilization was obsessed with uniformity, the golden ratio of bricks. Thousands of years ago, builders across a vast region used bricks with a fixed ratio. This was not accidental, it was the first evidence of applied proportional scaling. Decimal metrology. They used a sophisticated systems of weights and decimal ruler known as the uh, Mohenjo-daro ruler. Its units were remarkably precise, with divisions as fine as 1.7 millimeters, showing that their mathematics was grounded in trade and engineering. Vedic period and practical geometry. During the Vedic era, mathematics was closely linked with ritual and astronomy. The Sulba Sutras, composed between 800 and 500 BCE, provided geometric rules for constructing fire altars with precise shapes and areas. This text demonstrate Vedic period and practical geometry. Advanced understanding of geometry, accurate measurement techniques, early ideas resembling the Pythagorean principle, and this mathematician was practical and this mathematics was practical, exact and systematic, not abstract speculation. The Sacred Era, Vedic geometry, we are talking about 1500 to 500 BCE. Mathematics then moved from the street to the temple. The Sulba Sutras, rule of the chord, are the oldest known geometry text. Geometry from rituals. To please the gods, fire altars, Vedi, had to be built in specific shapes, falcons, wheels, or tortoises, each having an identical surface area. Calculating the square root of 2. These texts provided a formula that is accurate to 5 decimal places, an extraordinary feat for a cultural or for a culture using nothing but measuring ropes. And the Pythagorean discovery. Yes, the Buddhayana Sulba Sutra contains the first clear statement of the Pythagorean theorem centuries before the Pythagoras. It describes how the diagonal of a rectangle produces an area equal to the sum of the areas produced by its sides. Mathematics meets language, the binary insight of Pingla. One of the most remarkable early breakthroughs came from Pingla, a scholar of Sanskrit prosody around the 3rd century BCE. While analyzing a poetic matrix, Pingla developed a system to describe all possible combinations of long and short uh, syllables. In doing so, he effectively uh, created a binary style counting system, a structured method for generating combinations, and early versions of what later become Pascal's triangle. And though intended for poetry, these ideas now lie at the heart of computer science, digital encoding, and algorithm design. The linguistic era, Pingla and logic, 3rd century BCE, we are talking about. In a unique twist, the next leap came from poetry. A scholar, Pingla, wanted to map out every possible patterns of long and short syllables in Sanskrit words. The binary system to organize these patterns, Pingla invented a system of ones and zeros. This is widely considered the earliest ancestor of the binary code used by computers today. So we have, we can proud of all these discoveries from Ramanujan to Aryabhat to Brahmgupta to Pingla we are discussing today. The Pascal triangle, the Pingla created a pyramid of numbers called a Meru Prastara to count these combinations predating Blaise Pascal by over 1500 years. The revolutionary concept of zero, now we are talking about Shunya, discovery, the emptiness of emptiness of number, the idea of sunya or shunya, emptiness, existed philosophically in India for centuries. Its transformation into a numerical and mathematical entity was revolutionary. The Bhakshali manuscript shows that use of a dot as a placeholder in calculations. Merchants and astronomers used blank spaces or symbols to represent absence in numerical positions. Formalization by Brahmagupta. In the 7th century CE, Brahmagupta formally defined zero as a number and described how it behaves in arithmetic. This was the first time in history that zero was treated with full mathematical legitimacy. And formalization by Brahmagupta, the single idea reshaped arithmetic, algebra, accounting, scientific computation. Without zero, modern mathematics and modern technology would be unthinkable. So, let us appreciate, enjoy the moment of mathematics, the National Mathematics Day, and we'll meet again. तब तक के लिए नमस्कार.